Hello and welcome. I'm Jarvis, and in this lesson, we're going to dive into one of the most powerful features of SQL, summarizing data. We'll explore aggregate functions and the group by clause, which are essential for turning raw data into meaningful insights. By the end of this 22-minute session, you will be able to confidently use the 5 key aggregate functions to summarize data, understand how to group that data for more granular analysis using group by, and finally, filter those groups with the having clause. So, what exactly are aggregate functions? Think of them as powerful calculators built right into SQL. They take a set of values from multiple rows, like a list of prices or a count of orders, and return a single summary value. This is fundamental for any kind of reporting or analysis. Let's start with the most common trio. Count simply counts the number of rows. You can use count star to count all rows, or count column name to count non-null values in a specific column. Sum, as the name implies, adds up all the numeric values in a column. And AVG calculates the average value. These 3 are the bread and butter of data summarization. Let's imagine we have a products table. To find out how many products we have, we'd use select count product ID from products. To get the total number of items in stock across all products, we would write select sum units in stock from products. And for the average price, select AVG unit price from products. Each query gives us one single powerful number. Next up, we have min and max. These are incredibly straightforward and useful. Min scans a column and finds the smallest or minimum value. This works for numbers, dates, and even text, where it finds the first value alphabetically. Max does the opposite, finding the largest or maximum value. They are perfect for identifying outliers or ranges in your data. Using our products table again, if we wanted to find the price of our cheapest product, we'd use select min unit price from products. To find the price of our most expensive item, it's select max unit price from products. Simple, fast, and gives you the boundaries of your data at a glance. These functions are great, but they give us a single answer for the entire table. What if we want to know the number of products per category, or the average price for each supplier? Just using select average unit price doesn't help us there. We need a way to break down our data into groups before we aggregate it. And that is precisely what the group by clause is for. Group by consolidates rows that have the same values in specified columns into summary rows. It essentially creates buckets or groups of data, and then the aggregate function runs on each of those individual buckets. This is where SQL shifts from simple data retrieval to powerful analysis. Let's revisit our product category problem. To get the average price for each category, we would select the category ID and the average unit price. Then, crucially, we add group by category ID at the end. SQL will first group all products by their category ID and then calculate the average price for each of those groups, giving us a neat summary table. Now for the most common pitfall beginners face. The rule is this: any column in your select list that is not inside an aggregate function must be in your group by clause. If you try to select a column that isn't aggregated or grouped, SQL Server will give you an error because it doesn't know which value to display for the group. Remember this rule and you'll save yourself a lot of headaches. You aren't limited to grouping by just one column. You can create more detailed subgroups by adding more columns to your group by clause. For example, we could find the total units in stock per supplier and then break that down further by category. The query would simply list both columns in the select and group by clauses like this: group by supplier ID, category ID. Okay, so we have our groups, but what if we only want to see the groups that meet a certain condition? For example, show me only the categories with more than 10 products. We can't use the where clause here because where filters rows before they are grouped. For filtering after grouping, we need a new tool, the having clause. Building on our previous example, let's find categories that have an average price greater than $50. We start with the same group by query as before. Then, at the very end, we add having AVG unit price greater than 50. SQL first groups by category, calculates all the averages, and then the having clause discards any group that doesn't meet our criteria. It's helpful to understand the logical order SQL processes these queries. It starts with from, then where filters the initial rows, then group by assembles the groups, then having filters those groups, and finally select presents the results. You can also add an order by at the very end to sort your final output. All right, it's time to put this into practice. For this exercise, we'll use our books and authors tables. Your task is twofold. First, count how many books each author has written. Then, as a second step, modify your query to show only the authors who have written more than one book. Pause the video now and give it a try. Welcome back. Let's walk through the solution. For part 1, we need to join authors and books on author ID. We select the author's name and use count books.bookid to count their books. The key is to then group by authors.authorname. This gives us a list of every author and their total book count. Now for the second part. We take our existing query and simply add a having clause at the end. The condition is having count b.bookid greater than 1. This filters our grouped results, removing any authors who only have one book, leaving us with our final desired list. Great job if you got that right. You might be wondering where you'd use this in a real job. Imagine a sales database. A very common request is to calculate total monthly sales for each product category. You would select the category, the month from the order date, and the sum of sales. Then you'd group by the category and the month. This kind of summary report is vital for business decision-making. Let's quickly recap what we've learned. Aggregate functions like count, sum, AVG, min, and max perform a calculation on a set of rows to return a single value. The group by clause is used to create summary groups from your data. And the having clause is used to filter those groups based on an aggregate condition. Remember the golden rule. What's in the select must be aggregated or in the group by. You now have a solid foundation in one of the most important areas of T-SQL. I encourage you to practice this. Try grouping by different columns and using different aggregate functions on your own tables. Thank you for watching, and I look forward to seeing you in the next lesson.